So now we're going to look at some applications of Gauss's law. Here we're going to look at the location of excess charge on a conductor. When charges inside conductor are at rest, the electric field E is zero at all points in the interior of a conducting material. If E were not zero, the charges would move along the lines of force, and we would not then have an electrostatic situation. We can, for example, imagine a Gaussian surface inside the conductor, such as a surface A here. Because E equals 0 everywhere on this surface, so E will equal 0 everywhere on this surface, requires that the net charge inside the surface be zero. Collapse this surface down to an infinitely small surface, still E will equal 0, so charge must be zero at that point. We can do that anywhere inside the conductor, so there can be no net charge at any point within the conductor. Thus, any excess charge on the conductor must be located only on its surface, as shown. So, I've just read my notes there, but what that basically means is if you've got a solid conductor, all the charges are going to propagate to the outside of that conductor almost immediately. So if you place charge on the conductor, nothing's going to remain inside the conductor. It's all going to be distributed evenly around the surface. So, you know, if you construct an imaginary surface inside the conductor, you know that that surface is not going to have any field on it. Okay, so then you know that every point within the conductor has zero charge in it. So basically, what I've written on this diagram here is E is zero at all points in the interior of a conducting material when charges inside are at rest. You know, so I mean, if for example you were able to say drill a hole in there and drill some hole and stick in, some charge within that hole. As soon as you put the charge there, it will immediately redistribute itself on the outside. I mean, it'd be like momentarily will it all remain in there. I mean, that's what happens. Charge always distributes it on the outside of conductors. If E were not zero, then charges would move along lines of force, field lines, and we would not have an electrostatic situation. So yeah, I mean, if you did drill a hole in there and place some charge in there, there'd be some movement, because obviously there'd be a difference between the charge in the inside of that hole and the charges that are accumulated on the surface of the conductor. So momentarily you'll have a field, you'll have a potential between the charge here and that, so that was going to produce an electric field, and those charges are then going to move towards the surface, or they're going to move away from each other if all the same. So eventually you'll just have this conductor with the charge all distributed on the outside. Hence, excess charge on the conductor must be located only on its surface, as shown.